Hello students, myself Saurabh Kumar, and in the last class that we have discussed up to field of view and law of reflection, including the field of view as well as the vector form of reflection through plane mirror. So today I am going to discuss the minimum length of mirror required to view the full image in a plane mirror. So minimum length of mirror, concept of minimum length of mirror. So see, it is the sufficient length that will be, it is that minimum length which will be sufficient to view the full image of the observer. Okay, view the full image of the object. Okay, so let us take one example. We will learn with the example also here. So let me tell you, let's say this is a mirror, okay, and here it is an observer standing in front of mirror having eye very nearly to the head. I am assuming that the eye is very close to head at this case. Okay, now how we have to trace the ray diagram and how we have to find out the minimum length of mirror? Just see this. Let's say this is the surface. Now first of all, what we have to do, we have to trace a ray diagram such that the ray should incident from the top to bottom of the object. That should cover the whole range of the object. Okay, means whole portion of the object. Okay, and it should get entered after the reflection into the eyes of observer. Okay, so here let's say this is the incident ray from the toe, and it will get entered into the eyes of observer, which is the object itself. Here also the ray will incident from the object and it should get entered in the eye of observer, which is the object itself. So in this case there is observer and object, both are same. So here the image will form. Let's say this image is somewhere here, just extending the reflected ray, and we will get the image. Okay, so this will be the required image of the observer, of the object. So we have to find out this minimum length. This will be the minimum length of mirror that we are willing to find out. Okay, so let's say this is h. Okay, let's say some consideration, this is x, the distance between object and mirror. So this will also be x. Okay, height of object is given, it is given as small h. Okay, now let us consider this larger triangle is similar to this smaller triangle. So we can find out, applying similar triangle property, we can just write x upon h. Here just naming them a, b, c, e and f. So triangle ABC is similar to triangle AEF. Now x by h will be equal to 2x by this small h. So here what we will get? We will get capital H is equal to h by 2. So this is the minimum length of mirror which is required to view the full image of an object which has height h. So here we can observe that minimum length of mirror is half of the object side, half of the object side. Okay. Height of object. Let us take second case. Okay, let us take another case and trace the ray diagram for this. So let's say this is the mirror, plane mirror, and here it is object, and now the object has, at this time I am not assuming anything, so let us say this is here, this is the top portion of the hair. Okay, and this is the okay. Now just trace the ray diagrams. This is the surface. Okay, so let us say now how we have to trace. From the top of the object the ray will incident and it will get entered into the eye of the observer. This time only this object is observer also. Okay, there can be some other case we will discuss later. In those cases the observer will be different. Okay, see, so here this is reflected ray, sorry, this is incident ray, and this is reflected ray. Here also this is incident ray and this is reflected ray. Now tracing the reflected ray or extending it to the back side of the mirror. Here we will get the image. So again we will get a similar triangle, two similar triangles. Let's say this is A, this is B, this is C, E, and this is F. This H we have to find out. Now here let's say this from top to I it is H1, from I to bottom it is H2, and H1 plus H2 let's say is equal to H. Okay, here the object distance is as same in above case X, and the image distance will also X. Okay, this is object, this is image. So let us write the similar triangle property for triangle ABC and triangle AEF. Okay, so AEF and ABC are similar to each other. So here we can also write H upon X will be equal to, this will also be equal to H upon 2x. This x will be cancelled out and H can be given as H by 2, which can be also given as H1 plus H2 by 2. So here also we can see that the minimum height of mirror is half of the object height. Okay, same condition here also. Okay, now let us take another example. Let's say there is a room in which there is a wall and a plane mirror is placed. Okay, a room in which a plane mirror and a wall is placed. Now let's say this is the room and there is a plane mirror placed. At one side there is a wall and on another side there is a plane mirror. Okay, this is the plane mirror we are talking about and this is the wall that we are talking about. Okay, now let's say there is a person who is standing at the center of the room. Okay, at the center of the room he is standing at this distance and this distance, both are x. Okay, let's say there is a person which is standing at the center. Okay, now what we have to find out, we have to find out the minimum height of mirror so that this person can see the full image of the wall into his eyes. Here this is observer, this is observer, and this is wall is an object. And this is mirror. Okay, so question is minimum height of mirror so that observer can see full image of wall. Okay, that is the required question. So now let us find out. Okay, just erasing these things, let us draw the ray diagram. Okay, so see, let me draw the ray diagram here. Let's say the very important thing is that if this is observer, its eyes of observer. Okay, so the ray should incident through the top of the object and get entered into the eyes of observer. Let us draw the ray diagram first and trace it. Okay, so let's draw the ray diagram. Let's say the ray is like this, incident and reflected into the eyes of observer. Similarly, from the bottom of the wall, the ray should incident and get entered into the eyes of observer. Okay, so this will be the minimum height that is required to evaluate. So now tracing it, such as let's say this is wall, this is a man, and this is the mirror. Okay, they all are lying on the same plane. So from the top of the wall, the reflected ray has get entered into the eyes of observer. Similarly, from bottom of the wall, the ray has get entered into the eyes of observer. Now this height we have to find out. So just extending the reflected rays behind the mirror, we will get the complete ray diagram of the complete image of the mirror. Okay, complete image of the wall. It is the image of the wall that we have found out. Now see, this is the image of the wall that we have got. Okay, let's say here it is h, so this will also be h. Okay, if this is the distance that we have assumed, let's say x, this will also be x. Height of observer and height of wall. Height of observer, let's say, if you want to assume, let's say small h. Okay, or let's say some other assumptions here. Let us write it is y, and this is small h, the minimum height of mirror that we are required to find out. So here, what will be the minimum height? Applying the law of similar triangle. So h upon this distance. Yes, also one assumption that observer is at the center. So this is, let's say, a, and this will also a. Okay, this will also 2a. Okay, no need to assume x, and this will also 2a. So now here condition is given, observer is at center. Okay, so now let us apply the law of reflection. This is a and this is h. So according to this is wall and this is mirror. So in triangle A, B and C and E and F, so AEF and ABC are similar triangle. So applying h upon a will be equal to how much? Capital H upon 3a. A will be cancelled out. This implies h can be given as h by 3. Here we can see every time it is not coming half of the height of object. Okay, here height of mirror or minimum height of mirror is 1/3 of the height of object. Okay, so do not always remember that minimum height of mirror is half of the height of object. If the observer will be different, then that concept will be different. Okay, in that case we have to trace the ray diagram, and then we have to find out by applying the property of similar triangle. So here we have find out this. Again let us take another example. Let us see in another example, let us say this is a full face of a person. This is ear, this is eye, this is eye2, okay, this is eye1, this is eye2, this is ear1, and this is ear2, and there is a mirror in front of it. Those kind of mirror which are used for beauty products, okay. So same question, we have to find out the minimum length of mirror or minimum height of mirror. Let's say this is D1, okay. Let's say this is D1 and this is distance between eye and eye, okay. So this is D1 and this is D2. So we have to find out the minimum. First is minimum length when observed from both eyes. When this observer is observing his image from both the eyes, okay, I1 and I2. So let us trace the ray diagram. So same thing we will do again. If the full face, if the image of the full face, it has to be observed, then from the end of the face the image should emerge and get entered into the observer eye, which is itself the object. So let's say this is incident ray, this is reflected ray, okay. So let us draw it correctly. From one end it has incident and then it has reflected to eye, okay. Again this should get entered into the another eye, okay. Like, so this is the incident ray and this is the reflected ray. This is the incident ray and this is the reflected ray. Similarly from the second eye, second ear, okay, the ray should incident and reflected. Similarly ray should incident and reflected. So this would be the minimum length of mirror, where this is incident and this is reflected, this is reflected ray, this is incident ray. So this will be the minimum length of mirror. Let's say this is H, okay. So we have to find out this H. So here also we will find that this H will come out D1 minus D2 by 2, okay. Similarly, if we will observe if we will observe minimum length, if we will observe only one eye, okay, if we will observe with only, if observing from one eye, then h will be equal to d1 by 2. Okay, this is the basic concept. Now after that we will move towards the deviation in plane angle. Okay, plane mirror. So deviation in plane mirror, let us start studying the deviation in plane mirror. See, deviation in plane mirror. So what is deviation? Deviation is that angle when incident ray deviates from its initial path during the reflection. So that angle through which it gets deviated is called deviation angle. Means, if let's say it is a plane mirror and it is an incident ray which incidents and then reflected, and it is incident ray, it is reflected ray. So the angle at which this incident ray has deflected through its path, okay, so let's say extend this path. So here we can see that this incident ray has deviated to this angle, okay, and this angle is called angle of deviation or deviation angle. Okay, deviation angle. So we have to write always the deviation angle with direction, okay, with direction. Always write the deviation angle with, always write deviation angle with direction, okay. It will be suitable, and it is very important to mention the direction. So here let us say this is the normal, okay. Let's say this is incident angle, let's say it is theta or I, it is also theta or I. So this angle can be given as del is equal to pi minus 2 theta or pi minus, let's say angle of incidence is I, so 2I, okay. Here I am just writing I is equal to theta, okay. So del can be given as pi minus 2I and in anti-clockwise direction. So here I am mentioning the direction in anti-clockwise. So now here we can write the relation between del and I, okay. Let us draw one graph between del versus I. So see, this is, let's say, y, and this is minus 2x that is minus mx plus c. This is in this form. So we can trace the straight line having negative slope, okay, and this will be the graph of del versus I, where this is our del, this is our I, this point will be, and this point will be. So at I is equal to 0, del is equal to pi, so here pi, at del is equal to 0, I is equal to pi by 2, so here it is pi by 2. This is the graph of, this is the required graph, okay. And what will be the slope? Slope will be minus 2, okay. Now after that, let us take some another examples for the combination of mirrors and finding out the deviation angle. Let us take one example. So let's say these are the combination of two mirrors, and now we have to find out the net deviation. Let's say an incident ray incident on this surface and this surface and reflect to this surface, okay. So let's say this is, now find out the net deviation, okay. We have to find out the net deviation. Angle are perpendicular to each other, okay. So find del net. So here how we have to find out the del net? To see if this is the angle of incidence. So let's say this is the angle of incidence and this is the angle of reflection, okay. So now we have to apply the geometry. So let's say this is angle of incidence I, this will I, okay. So this is 90 minus I, okay. So just tracing the ray diagram so that we will get the so first and second, this is the incident ray which has reflected at this point. So here we can say that this angle is the angle of incidence and this is the angle of deviation. Let's say this is del 1. Now here also this is the deviation angle. Let's say this is del 2, okay. So they all are in same direction, that is anti-clockwise, both of them. So del net will be equal to how much? Del 1 ACW anti-clockwise and plus del 2 which is also anti-clockwise, okay. So let us find del 1 and del 2. So see, if this is incidence angle I 2I, okay, and this is del 1, so del 1 will be pi minus 2I. So for this we can write pi minus 2I. Now for this, what will be the value of this one? This is I, so this will be equal to 90 minus I. This will also 90 minus I. So this will be comes out pi minus 90 minus I into 2, okay. So plus of pi minus 2 into 90 minus I, okay. So here after calculating, the del net can be given as pi minus 2I plus pi minus this will equal to pi and this will equal to plus 2i. So this will comes out, cancel out, this will also cancel out. So del net will be equal to pi anti-clockwise direction. So see, here we can say that the reflected ray finally has just reversed its direction as the initially it has entered on the reflecting surface. Okay. Also here one point that should noted, that is this net is twice of the angle between mirrors. Okay, here angle between mirrors are 90 degree and this comes out 180 degree. Next, let us see another example. Let's say this is a reflecting surface. Okay, the combination of two plane mirrors is at any angle, let's say theta. So let us take the incident ray come in this way, reflect in this way, and then reflects in this way. Okay, there is also. Now we have to find out the same thing, that is deviation angle, net deviation. Okay, so how we can find out? Let us see. Now same thing, this is theta. Let's say this is angle of incidence I, this will also be I. Okay, so this is also theta. This will equal to how much? 90 minus theta. Okay, so here just tracing the rays, one and here another. Okay, so here we can write that this angle is in anti-clockwise and which is del 1. This angle is again anti-clockwise, which is del 2. So del 1 and del 2 both are anti-clockwise. Now what is del 1? So del 1 can be given as pi minus 2 into 90 minus theta. Okay, pi minus, this is I, so this will be 2i, this angle will be 2i, and I is equal to 90 minus theta, so pi minus 2 into 90 minus theta. Okay, that will come out 2 theta. In this sense, anti-clockwise. Similarly, del 2 will be how much? So this angle, if this angle is 90 minus theta, so this will how much? 90 minus 90 minus theta, so this will also theta. So this will be how much? This will be pi minus 2 theta. Okay, so if this is pi minus 2 theta, then see, now this angle we have found out. Now let's see here, this is 90 minus theta, so this will equal to how much, 90 minus theta, so 90 minus 90 minus theta is equal to theta. Okay, so theta plus theta, 2 theta, so this will come out pi minus 2 theta. So what will be the value of this angle? This angle will be 90 minus, this angle will be 90 minus pi minus 2 theta, which will be come out 2 theta minus 90. Okay, so this will the twice value, so it will be equal to pi minus 2 into 2 theta minus 90, which will come out pi minus 4 theta minus minus plus pi minus 4 theta plus 180. Minus 90, 2 theta minus 90. Okay, yes, okay, so here del net we can write, just adding all them. Okay, so we will get 360 minus 2 theta, this is the del net in anti-clockwise direction, direction, or you can say in other words it is 2 theta in clockwise direction. Both are same answer. Okay, these both are same answer. Now let us take some other example. Let's say, so in the previous question we have also seen that this deflection angle, this deviation angle is equals to the twice of this theta, but we have to mind the direction. Okay, this direction should be taken by tracing the ray diagram. Okay, now in the next, let's say another example. So let's say tracing another ray diagram. Let's say this is one mirror and this is another mirror. Okay, now this mirror is inclined at 60 degree. Let's say this is 60 degree. So let us find out the net deviation. So the net deviation can be given as same by tracing the ray diagram. So let us trace a ray diagram. Let's say this is incident ray which will diffract. Okay, so this is the first reflection, this is the second reflection. Now extending the reflected ray, let's say extending the incident ray, this is the first reflection and this is the second reflection. So now let us try to find out. See, this will be your first deviation angle which is in anti-clockwise sense, and this is your second deviation angle which is in clockwise sense. Okay, so here del 1 will be equal to how much? See, this is 60, so this will 60. So if this is normal, so this will 30. Okay, so the whole thing will be 60, so it will equal to 120. So 120 degree, this will also 30, so 180 minus 60 will be 120 degree anti-clockwise. Similarly, del 2 will be equal to how much? See here, if this angle is see, we need to find out this angle. Okay, so this angle is equal to this angle. So here this angle is 90 degree, this angle is 30 degree. Okay, 60, 60, so this angle will be 60, so this angle will also be 60, so this angle will also be 60 degree. This is 90 degree, so this angle will come out 30 degree. If this angle is 30 degree, so this angle will 60 degree, also this angle will also 60 degree, so this angle will also 60 degree, so this will come out 60 degree clockwise. Okay, 60 degree clockwise. So the net deviation can be given as 120 minus 60 is equal to 60 degree anti-clockwise. Answer. Okay, that's all about the deviation through plane mirror. In the next class we will see the next remaining topics regarding plane mirror. Thank you for watching.